let's get started. So in this playlist, we'll talk about a very important, a very uh, good framework called as Quartz. So Quartz is a open source job scheduling library that can be integrated with in virtually any Java application. So it can be a smallest standalone application or can be a part of a very large e-commerce system. So Quartz can be used to create simple or complex jobs, even tens and thousands of jobs, and these are defined as standard Java components that may execute virtually anything you may program them to do. So in our playlist, in our situation, we will be scheduling emails, and we'll be having an email job which will deal with taking up somebody's email, the subject and the body, and scheduling them as per we need. So you can have an email that is being sent out when a person has their birthday. You can send out a birthday email, or if you want to send them or remind them of something, you just schedule that as a reminder for somebody else. So this is a very good way to learn about how Spring Boot works with other variety of frameworks. Quartz being a great example, and we also learn how to actually build a real world example of what we are learning when it comes to concepts. So, in this video, we'll learn how to schedule jobs in Spring Boot using the Quad Scheduler by building a simple email scheduling application. The application will have a REST API that allows clients to schedule emails at a later time. We'll be using MySQL to persist all the jobs and other job related data. So this is the timeline for the videos. So we have our first video, which is the introduction of Quartz and creating the application. Next, we have configuring the MySQL database, the quad scheduler, and the mail sender framework. Third video is going to be about creating Quartz tables. So Quartz has a set of tables by themselves which they use to manage the data behind scheduling a job. So we look at that. Next, we talk about some basic terminologies which Quartz has to offer, such as job data map, job key, a query job descriptor, a trigger, and so on. Next, we start building our application from video 5, where we first create the request and response payloads. What information do we get from the user, the JSON, and what do we actually show them as the response. Then we'll be creating the controllers for scheduling email. So a schedule email, update email, pause or resume a schedule, and so on and so forth. Next will be a controller for getting the emails, following an email scheduler service, which is basically the heart of our application, the email job, which is going to be what you actually want to send in the email, and finally we'll be running and testing our entire API in the final video. So this is what we have in plan for the upcoming playlist. So make sure that you follow through, you watch all the videos, and please let me know if you have any doubts in the comments below. So let's get started. The first thing which we need to do is go to spring.io, start.spring.io, where we basically initialize our application using their web interface and directly start with a predefined project. So we don't have to worry about a new project, creating them from scratch on IntelliJ, etc., etc. So go to start.spring.io, give it a new artifact name. So you can just say email scheduler, and we need to add a few dependencies here. The first dependency is going to be web, second is going to be JPA, third is going to be Quartz. Next we go on to MySQL, and finally we end it with Java Mail Center. So these are all the dependencies that we need to actually start creating our email scheduler application with its REST API. So next, click on generate, and it will create a zip file or a compressed file which you can extract on your local machine, and then you can open it in your favorite IDE. So in my case, I'm using IntelliJ IDE for Mac, but any IDE which supports Java, Spring, and Spring Boot should work here. So this is the IDE which I use. It's free for Mac OS, free for Windows as well. You probably have a 30-day free license, so you can use that for this video and the upcoming videos. So let's get started. So once you have created your Spring Boot project, you have to open it in your schedule in favorite IDE, and you can see your project live here. So here, when you can see, if you go to source main Java, we already have a starter project ready in front of us, which we can directly start and see how it works. Next, we have our pom.xml, and here we have our dependencies that we need. So we have our JPA, we have our mail, Quartz, and web. Give it a good description. So Quartz scheduler or email scheduler. We can add an email scheduler for using Quartz, and you have a very simple project ready to make your first uh, scheduler using Quartz. So in the next video, we'll talk about configuring MySQL database, Quartz scheduler, and mail sender. So this will deal with the application properties of our application, where we add the server URL for MySQL database. We add some interesting configurations for Quartz scheduler, basically how it works, the ins and outs of Quartz, and also the mail sender. So we'll be using a framework which helps us schedule mail via code. So we need to also talk about some settings from Gmail, which we have to allow so that we are able to actually make SMTP calls from our code to the Gmail server. In the previous video, we talked about setting up a very basic Spring Boot application, which you can see here on the screen. It has a very simple starter, which just has a main function and runs the Spring Boot application. And we also now need to set up our run for configuration for our app. So in IntelliJ, what you can do is go on to this little piece of information, go to edit configurations. Now you need to select an application called as Quartz Runner and then run it. If not, you can also use the Spring Boot's way of running the application, but I would say the application way helps you to understand how Quartz or how a Spring Boot application works behind the scenes. So all you have to do is, let's do it again. So we do a plus application. We can give it a name as Quartz email runner, running it on local machine. The main class is something which we need to talk about. So it's going to be Quartz schedule application, and that's it. So that's all you need to have your runner ready, and you can always just run it whenever you want to. So that it gets easier to have a runner ready. You don't have to always click this. You can always click it here or the debug mode and then have your application running. So coming to this video, we'll be talking about the configurations or the properties that our application needs to set up Quartz, to set up the database, and also to set up our mailing properties. So we'll be using an email ID to actually send the emails, right? Or to schedule the emails. So we need to also set up some properties there. So let's get started. So go to resources and to application.properties. This is where basically we have all of our applications ready and the properties. So now what we're going to do is have them write the application properties for our application. So first comes the Spring data source. So the Spring data source is basically the database which will be connecting to your Spring Boot application, and some information regarding that, which includes the URL, the username, and the password. So let me write the ones for mine. I will not be giving it the values for now. I'll be doing it in the next video, because the next video is going to be dealing about configuring our database and how we can set up our MySQL server and integrate it with IntelliJ. So spring.data source.url, spring.data user name, and we can do spring dot username dot password. Now it is generally recommended that you do not have your password in plain text when it comes to enterprise applications or projects that you're deploying on, let's say, GitHub or anywhere else. So just for now, for practice purposes, we'll have our password in plain text. But if you're using this to create an enterprise application, or using it to create or deploy it on a provider or on GitHub, then make sure that your password is not there in plain text and it's modified or hashed in some way or the other. So this is the these are the properties that we need for our Spring data source, which is going to be a MySQL server, which we talk about in the next video. The second thing which we need is the Quartz properties. So let's start writing them. So the first is going to be Spring dot Quartz dot job store type. Now, as you can see, these have two options. One is JDBC, which we are going to use, where it stores your jobs in the database. The upside or the advantage of this is that whenever you shut down your application, then restart it again, it takes up all the failed jobs, or it restores the jobs from the database and then runs it again, so that you always have that job running. It's never in the failed scenario unless something happens from the user point of view. Next is storing it in memory. So this is basically a way of Quartz to store your jobs in memory only, not inside external database. So whenever you shut down an application and then run it again, the jobs get destroyed, and then new jobs have to be created whenever you restart an application. So since we need our jobs to be persistent and to be inside a database, we'll be using JDBC method or the value. The next is the thread pool count. So the Spring dot Quartz dot properties arg dot Quartz dot thread pool thread count. Maybe 5. So this is basically the amount of threads that you want your application to use when it's scheduling its jobs. So for example, if you have 2 or 3 jobs which are scheduled for the same time, you can have 5 threads in which each of the thread will have its own job running at the same time, so that it's less load for the application and for that particular thread. So next comes our mail properties. So since we'll be scheduling our mail, scheduling our mails, we'll have to have an email from which we send it from, and we also have to tell it what the protocol is, what kinds of things are we using. So let's add them. So the first property is the host, and since I'll be using Gmail to showcase the demo, I'm using Gmail Simple Mail Transfer Protocol, or smtp.gmail.com. So the next two properties are the port and the username. So port is basically the port in which you would want to send the mail through. So for here I have 587, and the username is my email ID. And you can also email me on this email ID if you have any doubts regarding your resume, if you want to talk about your cover letter, how to get jobs, how to get a software engineering job later on. So this is the email which I use. And next is going to be the password. So I will not be writing that here, but again, you should not have your password in plain text, but you should have them hashed. So Spring dot okay, so these are the basic properties that you need to make sure that your application has enough it needs to build up the email scheduling app. The next thing which comes in is two I would say necessary properties, one being the authentication and the other being start TLS. So we'll have that for now, and I'll talk about them later in the upcoming videos. So let's just input those properties now. So with these properties, now we have our application ready to start building it and then schedule jobs and schedule emails. But before we do this, we need to have an additional step which we need to make sure that we are doing, so that we have our emails which are actually being sent to the receiver. So since we are using Gmail by default does not allow you to send emails through a less secure application, and since we have literally no security in our application, it will be hard for us to actually let Google send our emails, and we'll just prohibit it or mark it as spam or just not send them. So what we need to do is go to this URL. So the URL will also be in the description below, and scroll down. So this is the security part of Google's account. Scroll down to less secure apps, and you should make sure that you turn it on. So you can click here when it says turn on, and then click it to turn on, and make sure that you do this only after reading what's happening here. I do not recommend this, it's just something which I have done. So make sure that this is turned on which you want to use the smtp.gmail.com for your particular email scheduling app. We talked about the Spring data source, and we'll be talking more about this and also setting up our database. Next is the Quartz properties, where we talked about our persistent jobs, where we store the jobs inside database, and also the thread count, which is basically how many threads would you want in your application to run your Quartz jobs. Next was the mail properties. We talked about using the smtp gmail.com host and having a username passwords ready, and also making sure that you have turned on allow less secure apps to use Gmail, so that you can actually send emails from your Spring Boot application to the recipient. Now, in this video, we'll talk about how we can configure our MySQL server and connect it to our Spring Boot application. So first, you need to have MySQL on your local computer. So I'm currently using a Mac. So for a Mac, I would suggest installing MySQL using Homebrew. So this particular link, which will be in the description below, will tell you how to install MySQL using Homebrew, and then you can start your services with just one command, which is this one. So using brew services start MySQL, you'll be able to start your MySQL server immediately, and then you can use it to create your databases. Okay, so now that you have you are ready with a MySQL server, let's go and start working on it and creating our database. So again, if you would like to set up your database using IntelliJ, you can use it via this, or we can use something called as Mysql Workbench. So Mysql Workbench is basically a GUI application for your MySQL server, and we'll just create a database here, and then we'll move on to using the IntelliJ database settings. So let me just create a database here. So as you can see, I have created my database, and if I refresh the schema, you can see Quartz demo right here. Now that we have our database ready, let's actually go and have it inside our IntelliJ application. So we can close this off for now and go to databases. Let me just delete this so that we can create it again. So remove. Okay. And let's go to plus data source MySQL, and giving it a name as Quartz demo. Now what we need to do is add our URL link. So the URL link is going to be as follows. You can almost use the same URL link. So let me just copy it and then show it to you. So MySQL server is running on localhost 3306. So as you can see here, so let me get this back, demo, and just paste the URL as it is. And it has a /Quartz demo because Quartz demo is what I'm using. SSL equal to false, allow public retrieval key true. So this is something which we'll talk about later, but it's important to have it here for our database to work. My username is root and my password is also root. So let's test the connection real quick so that we make sure that our database is connected to IntelliJ. And yep, succeeded. So as you can clearly see, we have our database ready. Click apply and you do an OK. So as you can see, we have our database ready here. So our SQL server here, Quartz requires us to create some of the tables using their SQL script, which they have. So the next step here is going to be using those scripts and running them here inside our MySQL console. So go ahead to this URL, which is again in the description below. And this is something which is given by Quartz itself. So all you have to do is copy the entire SQL list and then just exactly paste it inside your console. So I'm going to do that right now. I can just do it a raw. Do Command A, Command C, or Control A, Control C, and just paste it here. So let me do it here. Yeah, and these are all everything which Quartz requires you to have. So don't worry about this. You can go into this later, or you can see this later. So just make sure that you have this ready. And yeah, so if you want this in your Quartz file, again you can add this to your Quartz file. So let's do that as well. And great, so now we have this ready, we have our console ready. Also let's just do it without this so that we just make sure that we are not missing out on anything. Yeah, now all you have to do is run this. So we'll just click on run, and here you'll see how it's being run. So we can wait for some time. You can also view your database creation of tables in the database. So we'll do that in a minute. Let me just show it to you here for now. So that green tick shows that all of these queries have run. So let's wait for it to run all the others. So as you can see, all of them have been running. So we have finished creating a database. And to check whether the tables have been created or not, go to database, go to Quartz demo, and as you can see, we have all of our tables here ready. So if you would like to see what's inside the tables, let's look into that. So first we have our job details. So yeah, before we get into all of this, let's actually understand the terminologies which we need to know in Quartz. So here we have an overview of Quartz scheduler APIs and terminologies. Again, this link will be in the description below. So first we have the scheduler, which is the primary API for scheduling, adding, removing jobs. We can pause the jobs, resume the jobs, all of that. So it's the primary API or go-to API when it comes to dealing with Quartz. Next is a job. So a single unit of work which your application is going to do. So in our case, going to be scheduling the email. That is called as a job, and it's an interface to be implemented by the classes that represent a job. So you will be implementing the job class, and then it has a single method called execute, which you'll be implementing, where you write the work that needs to be performed by the job. Next comes in the job detail, which represents an instance of a job. Also contains additional data in the form of a map. So you have a key value pair, and then you can add some primitive data types as in that map. So we'll be having our from, to, subject, body of the email inside this particular job data map. Every job detail is defined with a job key, which is again consists of a name and a group. So this makes every job unique, a name and a group. Now next comes a trigger. So a trigger is basically when do you want your job to be triggered. So it defines the schedule at which the job will be executed, and a job can have many triggers, but a trigger can only be associated to one job. And similar to job detail, every trigger is identified by a trigger key that comprises of a name and a group, which again has to be unique within a group. Next we have a job builder and trigger builder, which is basically a way of creating job detail instances or creating trigger instances. So this is all you need to know about the terminologies in terms of Quartz, and all of them are fairly straightforward. Once you work with them for a few minutes or so, then you'll be very comfortable with them. And now we can go ahead and see what's inside our tables. So the job details tables has the scheduler name, which your local scheduler will be using, the job name, job group, description, job class name. So in our case, it's going to be email job, whether it's durable or not, whether you can update the data or not, and the job data which it has inside it. The next important table is the Quartz trigger table, the name of the trigger, name of the job it's associated with, and priority, next fire time, previous fire time, when it's going to get fired, and the trigger state, which tells you the state in which the trigger is. So it's acquired, waiting, running, all of that. So the other tables are also important, but you will mostly be dealing with these two particular tables. And this is how you actually integrate your Quartz tables inside a database, connect your database to a Spring Boot application. We talked about setting up our application.properties, where we set up the database, data source, URL, password, JDBC connection, SMTP, etc., etc. And in this video, we'll talk about creating our API. So we'll talk about how to can actually create a REST API, which will help us schedule those jobs, and then we will schedule the jobs using Postman. So in this particular video, we'll talk about the DTOs, or the data transfer object, that we'll be using to communicate with the user and Quartz. So let's get started. So first we need a new package. So let's go here and create a Quartz scheduler dot payload. So this package is going to consist of the DTOs. So we have a request DTO and a response DTO, and these DTO will talk to the user about the type of values that are needed to be entered. So for example, the email, or the subject of the email, the body, date, time zone, etc. So we'll be taking up this request from the user and then scheduling our emails via Quartz. So for that, we need to have a DTO, or a way for the data to be transferred from the user to our application server. So let's create a Java class called as email request. So now we need to add a few fields for our attributes for our class email request. So let's start with the most obvious one. So we have @email and @not empty. So these annotations make sure that our email, so private string email, make sure that our email is always in the form of an email and is never empty. So we just have to make sure that we have the right classes for that, so that we don't have to worry about the validation which has to be done on email, checking whether there is an @ or there's a .com or .n. So all of that is being handled by the email annotation. And yeah, of course, our email cannot be empty, so that's why we have a not empty annotation on top of it. Next is going to be the subject. So the subject also cannot be empty. There are emails which are being sent without subjects, but those are usually marked as spam, or they're not trusted. So we'll make sure that our application has a subject, again a private string subject. So next up is the body. So again, we don't want an empty body, so we'll make sure that a body also is not empty, and this is going to be body. Next comes in the date time. So the date time at which the email was sent, and for that we have not null, so it's different, and private local date time, we have the date time. And let's keep importing our classes as we go. Next up is the zone ID, or the time zone of the current place you're in. So if you're sending an email from India to, say, let's say Europe, then we have to have the appropriate time zones mapped at both the places, and this particular field takes care of that. Again, this cannot be null, because this will be there for all the emails that you sent. And private zone ID time zone. And yeah, so this deals with the email request, or the request which the user sends to the server. and this will contain the email to the sender's email. So for example, if I'm sending it to test@test.com, then that is added here. Next is the subject, which is the topic of your email. Next comes in the body, the date time at which it was sent, and the time zone from which it was sent. So this is basically what is going to be inside our email request. And let's add some setter and getter functions here. So we'll do a setter, and we'll also do a getter. So make sure that you download the Lombok LOMBOK plugin from here. So just go to files, sorry, not files, I would say go to preferences, and let's wait for it to come up. And here go to plugins and then download Lombok. And Lombok is going to help you with all the annotations that are required, which make your life like 10 times easier. You just go type LOMBOK, and yeah, so I have installed it. So if you haven't, then you can install Lombok, and then you can play with all of these annotations for your project. Okay, so this is our email request, the way we send it to the server. Now we need a response. So for that, let's create another payload. So new Java class email response. So this is the response we get from the server after we send our request. So this will consist of some variables such as success, whether the email was sent successfully or not, the job ID of the job group, and the message we get back from the email response. So let's create this now. So first we have our fields. So we'll be having private boolean success. Next is private string job ID. Private, oh sorry, make sure you spell it right. And make sure you spell it right again. You have job group. So each Quartz job is uniquely identified with job ID and job group. So you need both of them to have a unique job. There can be multiple job IDs inside one single job group. So we'll talk about that later when we come to it. Next comes in the private string message. We get back. Let's give it a nice name. And next we have the constructors for our email response. So email response boolean success and string message. Let's create the constructor. So this dot success equal to success, this dot message equal to message. So a simple constructor, nothing complicated. We'll see why we need the constructors later on when we create our API, but we need two types of constructors here. So let's create them. This one is going to have boolean success string job ID string job group and string message. This dot success again equal to success. Now as we write this out, we have to make sure that our variable names are rightly written. So make sure that you have the correct variable names and there is no spelling mistakes, and all of them is readable, pretty readable. Should not be something which is weird to read or to understand. So only by seeing the code, a person should be able to understand what's happening behind the scenes. Try to minimize the amount of comments you write. So make sure that the comments actually tell you why the code was written and not what the code is. So a comment like this here would not make sense, that this is a constructor. This is not a comment which is helping us understand anything about the code, right? So something which can be changed here is that we can write this constructor helps with so and so. So this is a way of actually writing good comments when you're creating a very big project, and also to make sure that if other people contribute to it, it is readable. So make sure that you write comments that explain the why behind the code and not the what. Okay, so last is the message. So this dot message is equal to message. Okay, great. So we now have all the fields ready, constructor ready, and this is going to be the response to our request that we send back to the server, and we get whether the email was successfully sent or the job was created successfully or not, the message we get back, and the constructors that are used for it. So the next thing is going to be the controller or the endpoints that handle or work with Postman or any other application that deals with API calls. So let's create our controller now. So let's go to a new package, call it web. The web is going to control the API endpoint. So let's create a Java class for that. It's going to be an email scheduler controller. Now this particular class will control all of our APIs. So it'll have the logic behind the APIs. And in this video, we'll talk about starting to implement our email scheduler controller, which handles the API endpoints for our application. So before we start implementing, we need to get in touch with two important concepts that we are going to use while we schedule our application. The first important concept is job detail, and the second is the trigger. So let's revise what they mean first. So a job detail represents an instance of a job. It also contains additional data in the form of a job data map that is passed to the job when it is executed. So the job data map or the job detail will include the email of the person to whom we are sending the email, the subject, the body, all of the information that we get from the email request. And the job data map will hold that for the particular job and will be passed to that job when it is executed. Now, every job detail is identified by a job key that consists of a name and a group. A name being the job ID, group being the job group which we have inside our email request. The name must be unique within a group. Now comes the trigger. So a trigger, as the name suggests, defines the schedule at which a given job will be executed. So the trigger basically tells Quartz when should the job be triggered. A job can have many triggers, but a trigger can only be associated with one job. So we need to read that again. So a job can have many triggers. So one job can have many triggers, but only one trigger can be associated to one job. Now every trigger is also defined by a trigger key, which comprises of a name and a group. The name must be unique within a group. Just like job details, the triggers can also send data to the job. Now these are the two very important components of Quartz that we'll be using to create our job detail and trigger for our API. We'll also be using the trigger builder and job builder, which is basically an API to construct these two above. So let's get started. Let's start creating our job detail. So we'll have a private. So I've left some space here to actually implement the API, but for now, for this video, we'll be implementing the job detail and the job trigger. So private job detail build job detail. So this is going to be our application which deals with making the job, and it is going to have the email request schedule email request as our arguments. And yeah, so let's import all the functions that we are supposed to, like classes. And yeah, so let's initialize it first. So job data map equal to new job So this is basically a map, a very typical map which Quartz uses, and we put on the information that we need to pass on to the job execution when we schedule it. So job data map dot put, and you can predict what we're going to do here. So we'll have the email is going to be schedule dot get email. Next, so the same thing again, and we do it for the subject and the body. So we have the subject, and this again becomes get subject. Great. And the next thing is for the body. Sorry about that. This becomes body, and this becomes get body. Great. So now we have the job data map, which is going to pass the information to the job and schedule the email using the email subject and body, which the job data map has. Now let's build our job detail using the job builder API. So return job builder dot a new job, and now will be dot with identity, and the identity is going to be UUID dot random UID dot to string, so a random name, a unique number name, random name, and the group is going to be email jobs. Now the next thing which we need to have is with description, and the description is going to be send an email job. The next part is using the job data map, so using job data, and the job data is going to be job data map. So this is the information that will be passed to the job. Next is going to be store durably. So this basically tells Quartz to store the jobs even without a trigger and persist them in the database. And the final comes with the build. So the build takes care of building the job. Now the new job takes in a parameter, and that parameter is basically the class in which the job is implemented. So the class which handles scheduling of the email, the meat of our Quartz application, that will be passed out here. So let me just create it right now. So email job dot class. Now we haven't created email job yet, so let's go ahead and create it now. So we'll create a new package first, and it'll be a Quartz dot job, and inside this we have our email job class. So let's go back ahead here and let's import this so that we don't have any errors for now. And great, so this has to implement a job, so let's make sure it does that. Let's go here and we should do implements Quartz job B, and when we implement the Quartz theme, we need to have a function here. So let me just write that for now. So we override protected void execute internal, and this is going to have the job execution context here. So it does not implement it, extends it, my bad. And yeah, so this is going to be the meat of our application, and we'll be implement this in some time. But for now, let's go back to our email scheduler controller, and this is the implementation for building a job detail. Next comes implementing the job trigger. So let's go ahead and work with that now. So here we do a private trigger build trigger, and this takes in the job detail, and it also takes in the zoned date time, or basically when do we actually start scheduling the email or start the trigger. And let's import this from Quartz. And now we can start implementing it. So we'll just go right ahead and build our trigger. So we'll do a trigger builder dot new trigger dot for job, and it's going to be the job detail dot with identity, and the identity is going to be job detail dot get key dot get name of our job, and the group is going to be email triggers. The next part is the description. So with description, so we send email trigger, and we start at, and we do a date dot from, and start at dot to instant. This is going to be the start time for our trigger, when should the trigger actually be triggered, and with dot with schedule, and we'll do a simple scheduler builder dot a simple schedule, which basically does with misfire handling fire now. So we'll come back to this and what this actually means and what is actually happening here. But for now, this is how we are going to schedule it. And whenever there's a mishandle, it'll just show us the misfire handling instructions and fire it again. All you have to do is dot build. And this is basically how we implement our trigger. So the trigger has the for job, which includes the job details which you're using. Identity is the unique name and group. Description, start at the point where it should start. And the schedule is basically a simple schedule which fires it with a misfire handling instruction and builds it using the trigger builder API. Now we have a job detail and job trigger. The next part is to implement the post API, which takes in the email request and then schedules our job. So in the next half of this playlist, we'll finish up building the email scheduler controller. We'll finish up building the email job, which handles the main heart of the Quartz application that we're building. And we'll also test our application using Postman and see it working live in action. So in this video, we'll finish up building our email scheduler controller so that we have a ready to use endpoint, a post endpoint, which we can use to schedule our emails. In the upcoming videos, we'll also create a get endpoint from which we can see all the emails that we have scheduled, and also look at how the database looks behind the scenes after we put in some information from Quartz. Okay, so let's continue building, or actually finishing building our email scheduler. We need a bit of annotations here. So we need a logging annotation so that we can log some of our messages. We need a REST controller to make sure we have REST controlling mechanisms on our application. Now we need the scheduler that we are going to use. So let's do an auto wire of private scheduler. Awesome. Now we can use the scheduler to schedule our jobs and make sure that all of them run when we want them to run. Let's go ahead and start creating our post mapping. So let's have a post mapping annotation. This is going to be the sort schedule email. So you can have multiple things here. So you can have schedule email, schedule a job, anything which you would like. For the simplicity of this tutorial, we'll be going with schedule/email. The next comes in the method declaration. So it's going to be a response entity that will be sending back, and it will have the body of an email response and the function name. Now let's have some parameters here. So it will be a valid request body, which is going to be an email request. Okay, so this is our method declaration, where we actually implement our schedule email for the Quartz application. Now let's go ahead and start implementing it. So let's wrap the entire method inside a try catch block where we are able to catch any of the exceptions. So mostly we'll be having a scheduler exception from Quartz which we need to handle. So we can do a scheduler exception se and just do a log.error here, error while scheduling email, and also give out this so that we are good to go. Now once we give this out, we need to make sure that we also give out a response, an email response back to the user who's using it. So what we can do is we can create a new email response object. And if you remember how this looks like, let's actually go and see this. So we have a constructor where we have the success and message. We also have another constructor where we have the success job ID, job group, and message. So which one do you think should we use here? So here we'll be using the first one where we just do a success as false, and the message is going to be error while scheduling email. Please try again later. Can be as descriptive as you want it to be, so that's up to you. And let's have it down so that we can see it. And all we do is we return this back. So return response entity dot status. There's going to be a HTTP status of internal server error. So let's find that, because it was an issue by because of Quartz. Dot body is going to be an email response. Awesome. So now we have we are able to successfully catch our application which our method might throw, and the next part is to implement the post structure for our method. So first, let's actually get the zone date time using this date time, the zone ID and the date which we take from the email request. So if you go to email request here, you can see that we're asking for the date time and the time zone. So now we need to configure that into some property which Quartz understands, which is going to be zoned date time. Let's call it date time only. It's going to be zoned date time dot of email request dot get date time, comma email request dot get time zone. Awesome. So now we have our date time. Next, let's do a quick conditional to make sure that the date time dot is before zone date time dot now. So if it is scheduled in the past, then we cannot actually send it to the user. We can't schedule it, right? So if we are scheduling it in the past, then we have to tell the user that the date must be after the current time. So let's just do an email response there. So let's do an email response equal to new email response. And since it's a failure message, it's going to be false, and the message is going to be date time must be after current time. Great. Let's get this down so that we have enough space to see it inside our single window. Great. Okay, and now we can just return this back. So I'll just copy this return method and paste it here. Okay, now comes the part where we actually deal with the Quartz part. So first let's build our job detail. So we do a job detail is equal to build job detail, and we pass it in the email request. So this is what we had built in our previous video, where we pass in the email request, we create a job data map, and then we build a job using the job data map, which has the email, subject, and body. So now that we have finished implementing that, we can use it to get a job detail back. Next is going to be a trigger, which is going to be equal to build trigger email request. And now we have our job detail and the trigger ready. So okay, so here I think we made some changes. So it's going to be the job detail and the zone date time. My bad. So this is going to be job detail comma date time. Great. So now we have the job detail and the trigger ready. So the next part which we need to work on is scheduling the job. So this is how simple it is to actually schedule a job using Quartz. So we use the scheduler dot schedule job, and all you have to do is pass in job detail and the trigger, and voila, that's how we schedule a job using Quartz. So it is that easy to use the framework because it gives you out of the box functions to use and schedule jobs. And of course, if you would like to see how it works behind the scenes, you can click on the scheduler Java and see how it works behind the scenes, which I really highly recommend to do so. The next part is about sending back the response to the user. So in this particular case, we were actually able to schedule a job, right? So we should be able to send back a positive or a true success email response object. So let's create that. Email response is going to be new email response, and the success message is true. And let's send back the job detail dot get key dot get name, and also the group. So job detail dot get key dot get group, and let's send a message with this, which is going to be email scheduled successfully. Great. And now that we have this ready, let's send back a response entity. Okay, email response. So this is how we implement a post request for our Quartz scheduler, where we are able to schedule an email. So let's really quickly go through what we have built here and make sure that we haven't missed out anything here. So first, we make sure that our controller has all the required annotations. So since it is a controller, it has a REST control annotation. We'll be using our logging functionality to make sure that we catch the errors while we are in development. So we have the SFL4J annotation. Next comes in the auto-wired scheduler, which we'll be using, which is given by Quartz. And we use that to create our post mapping. But before we do that, we have two helper functions, which is the build job detail and build trigger, which help us build the job detail using the job data map, and also the trigger using the trigger builder to make sure that our jobs are scheduled at the right date time and with the correct job information. Next comes in the schedule email method. So here we first convert our date time and the time zone into a zone date time, which is a standardized form to make sure that we have the date time from any time zone across the world. We then check if the time, if the scheduling time is before the current time. If so, then we return back an internal server error, or actually we do a bad request here, because this is something which the user did incorrectly. So we have to tell them it's a bad request to send, and we send a message that the date time must be after current time. Now, if the user has passed through this, or in other words, if the date time is after the current time, then we move on to building the job detail, building the trigger, and then scheduling the job using the schedule job method. Next, after we do this, we then create a new email response object with a true success boolean, the name and the group of the job, and the email scheduled successfully message, and send that back to the user using an OK status, which is the 200 status code. So this is how we create a post mapping, and our email scheduler is completely implemented. In this video, we'll start implementing the last part of our application which is implementing the job. So let me show it to you right now. So we have a email job which we need to fill up. So basically we need to tell the application what happens when a Quartz job gets triggered. So when it gets triggered, it goes inside the execute internal method, and this gets invoked whenever the time comes to it. And then we use the job execution context to handle the things that happen around the Quartz application and the job. So now, first, we haven't actually run our application yet. So it's been 6 videos and we haven't even run it once. So let's first do that right now and make sure that the application is running. So for that, let's actually write a very simple get mapping. We'll just throw out a string saying that this is a get method, and we'll just run that on the browser to see whether our get API is working or not, so that we can make sure that our application is up and running. So let's do that quickly. We are get mapping. This has let's say a get, just a get should be enough, and public response entity of string. So we have a response entity which is going to be a string, and this is basically going to be a get API test. And let's implement this. So all we need to do is basically return response entity dot okay, and the body is going to be get API test pass. And yeah, have this. We are getting an error here, so let's just see what the error is. Yeah, no errors, all good to go. So this is basically our get API which you're going to use to print out get API test pass and make sure that our application is up and running. So before we run our application, make sure that your data source URL and your data source stuff is filled up. This we'll fill it up later. This part we'll do it once we start implementing our sending email logic using mail properties and Java mail sender. So for now we just need to run the application. So have your data source filled up. Let's actually go and run it now. So you can just go here and use this handy function. Okay, so before we do this, make sure that the SQL server is up and running. So let me just do it right now. Brew services start MySQL, so that when we run our application, we automatically connect to our MySQL database. Let's check that here. And so we used to set it up here as well. Let's do a refresh, and yeah, so we have our Quartz demo up and running. Now we can go ahead and start running our application. So let's get this to the side, close this, go inside Quartz Studio and hit run. Now once we make sure that the application is up and running, the next thing to do is to actually start implementing our email job. And in this video we'll implement the part regarding the job execution context, where we need to understand how that works, and the next video we'll actually implement the send email logic. So that is the amount of stuff we're going to do for this video. So let's wait for our application to run. So we have our Hibernate ORM running, GPA is running, we have our Quartz scheduler running locally with 5 threads, and yeah, we have our application running on port 8080. Let's quickly check this out. So 8080, we do a get, and as you can see, we get a get API test pass. That means our API, our REST application is working perfectly. Let's go ahead and close this now, and now we can start implementing our email job method. So if you remember, when we go to the controller, we are filling out some details inside a job data map. So all of the data which we fill out here, this we use it when we actually get inside the execute internal method, and we get that job data map back using the job execution context. So let's see what I mean by that. So now we do a job data map, job data map, job execution context, get merge job data map, and that is how we get back our job data map. And now basically what we do is fill up our boilerplate. So we need to extract some things here. So we need to extract a subject, which is going to be job data map dot get string, and this is going to be subject. So what we're doing here is that the job data map dot put, which we put here, we're just taking that back out in the execute internal method, and we do the same thing for the body. So we just do this as a body, and this is going to be body. And the last thing is the recipient's email. The recipient email. I'm not sure if I spelled that right, but let's just assume that I did. And oh, my bad, did not have to run this. And this is going to be email. Yeah, so let me just check that real quick here. So we have email, subject, body, all good. And now that we have the information regarding this, what we need to do is send that information to our send email logic. So we can do a send mail, and this is going to have a lot of stuff. So let's implement it here. So private void send mail. So this is going to have a from email. So it's going to have a string from email, string to email, string subject, and string body. And make sure to spell everything right. So this is basically what we have for our application. And now we need to implement send email. So before we do that, in the next video, in this video we talked about setting up our REST application. So we had our data source ready, we had our MySQL server ready, and then we used all of that to run our application and then see out the get API. Then we talked about email job. So here what we did was we talked about the execute internal method. So this method is invoked when the Quartz job is triggered. So if suppose we schedule an email to be sent at 12 a.m. in the morning, then at 12 a.m. this method starts getting invoked, and then you get the job data map, you get the subject, body, recipient email, and send that to the send email function. In this video, we'll talk about implementing our send mail logic, which is the crux of our application, which we use to send an email to the recipient. And let's just get into it directly. And once we finish implementing this, we'll just talk about running the application again. And in the next video, we'll start testing our application using Postman. So cross out the update notifications and let's get into it. So first, let's add some annotation. So we want this to be a component bean. So we add the component method here, and now we need two beans. So first is an auto-wired private Java mail sender. So this basically helps us send the mails. And another thing which we need is a private mail properties. Okay, using these two, now we can implement our send mail functionality. So send mail, first what we need to do is get the username. So what we do is a mail properties dot get username. Next is the recipient email, or the to email. Comes after that the subject and the body. Now let's start writing our send email logic. So let's wrap all of this around a try catch. So a try and a catch. So let's first write a mime message. This is going to be a message, and we create that. So mail sender dot create mime message. Next, we use a message helper from mime. So my message helper, and this is going to be equal to a new my message helper, which is going to have the message, the standard car sets. It's going to be UTF-8. This is just boilerplate code that I'm writing for sending an email, so just make sure you have that in it. So to string. Now that we have a message helper, we can add additional information to it. So we can do a set subject and then add that. We can have a message helper for setting up text, and that is going to be the body and in HTML. Let's check what the issues are here. So yeah, we need to catch something, so we'll do that right now. We need to catch what? We need to catch messaging exception. So we do a messaging exception here, and let's log the error. So all you have to do is system.out.println the exception. And now let's head back to this. So we need to do a message helper dot set from. It's going to be the from email, and the final part is the to. The message helper dot set to. It's going to be to email. And now the last thing which we need to do is sorry, mail sender dot send message, and this is how we implement our send mail logic. So let's go through what we did here. We did a couple of things. So we used the mail sender bean to send our email over the email protocol that we have, and we use mail properties to add the metadata for our email. So we added helpers using my message helper, where we added subject, text, from, to, all this metadata, and then we send our message using the mail sender. And this is basically how we implement a send email application. So let's go through everything again from the beginning and see the flow of our application, because since this is a relatively complicated tutorial than what I had posted before, we need to make sure that we did not miss out on anything. So first, the properties. We have our Spring data source. We have the Quartz properties here. We are using JDBC. We have our mail properties. This is going to be blurred out, so I will not be adding the password here. And we have our simple mail authorization stuff. Next comes the scheduler controller. So here we have a post method which schedules an email, takes an email request. So let's see our email request. The email request has the email, the subject, body, date, time, etc. Then the response has the success, boolean, job ID, job group, message, all of that. Then when the time comes, the email job is triggered, gets the job data map, and then sends the email using mail sender and mail properties. So let's get started. So before we jump into that, we'll just go through the implementation real quick, and what have we done before, and where we are right now from video 1 to video 9. It's been a long journey. So let's go through all the classes real quick right here, and once we're done with that, we can then move on to testing the application. So here we have our application or properties, which basically has your data source, your MySQL stuff, and also your mail properties, your email ID, your password, etc., etc. Next is your email request, which basically is the payload or the info data that your client inputs and sends as a body in a post request, who gets a response back in terms of an email response body. And yeah, so one thing which we want to talk about here is that this was not there before, and make sure to add this in your code, and the setter and getter as well. So this basically makes sure that all the non-null values are also included inside the JSON when it gives an output, and the setters and getters are basically, well, setters and getters for the class. Next comes in the email job, which basically is the heart of our application. It uses mail sender and mail properties to then create the message and then send it. And we also handle job execution context and the job data map in this set of lines of code, and make sure that the appropriate email is sent to the appropriate person. And finally, we have our controller. So if you go inside web, we have a controller which handles everything for us. So it handles scheduling of emails, it handles building the job detail, the job trigger, and also scheduling the job for us, and does some basic validations. Uses these helper functions here, build job detail and build trigger, to make sure that we are up to date with our stuff. Okay, so let's test it now. So let's run it first, and we'll be using Postman to test the application. It's an API client, so make sure that you have Postman installed inside your laptop or a computer, or if not, then any other API client works. So we have our application up and running. Let's open Postman. And so first what we're going to do is we are going to do a get request on /get. If you can see here, we had made a simple get mapping just to make sure that the API is working. So my bad. Go to Postman, get this up and do a send, do a get request, and we'll just make sure that we get back the pass. So our REST API is working, and now let's do it. Let's do a post and schedule an actual email. So here I'm scheduling the email to myself, and the subject is one lead coder day keeps unemployment away. Pretty important stuff. And the body is that you either reverse a linked list or you just get out. And date time is in this format, so it's the date and then T, then hours, minutes, seconds, and the time zone is Asia, Kolkata. And yeah. So first, before we actually do a successful post, let's actually mess with it a little. So what if I put this as 06 and this as 29? This is basically before time, so this should give us an error. So as you can see, we have our error message that the date time must be after current time. So our validations are working pretty fine. And all I have to do now is make it as 07 and send our request. And we get back the output as true. This is the job ID, job group, which we had used to schedule the email. And that's it. That's how we actually run our application. And we have scheduled an email to be sent to me next month this time. So now, if you are still not convinced of whether the email was sent or not, what you can do is use a debug mode inside Quartz. So let's actually do that right now. So let's stop the application and run it again using debug mode, and then you can see every single state happening step by step. You can see what your variables are, what's happening behind the scenes, etc., etc. So let's actually do that right now and see how a debugger is used inside IntelliJ. So let's say I want to keep track of everything that happens. So I want to keep track of which request is coming in and where is it going out, all of that. So what I can do is I can create breakpoints. So if you click on a line here, it will stop the execution of the program for that line. So let's say I do it here. So everything before this, all the variables, I can see them inside the debug console, and we'll see that in a minute. So I want to stop it here and see what is inside my email request. I want to see what's inside date time. That way I can see it here. And then I want to see the response, right? So I want to put a breakpoint here and see the email response that I get back. Now what you have to do is run it using the debug mode. And this takes up comparatively a bit more time to start when you compare it to the run button, because it IntelliJ does something behind the scene for it to make sure that the breakpoints are being actually hit. Now once this is done, should be over anytime now. And yep, now what we have to do is go to Postman and do a send here, basically trigger our process. And once we do that, you'll see that we go inside the debugger console. So give it a minute. And yep, so now we are inside the debugger console, and here we can see all the variables before line 40. So this is the current object of the email controller. We have our email request. So this is what we had sent using Postman was this. We can see exactly how we want to see. We can see the date, we can see the time zone, Asia, Kolkata, rules, all of that stuff. Very, very interesting, very nice stuff to see. We can see our date time and also the scheduler which we had, declared here. And let's do a resume program, and then we get the email response. So now we have an email response and we can see what is happening behind the scenes in the email response. So yeah, pretty cool stuff, a pretty interesting way of seeing how the program works behind the scenes. And now you can actually move around and see how each and every state changes when it goes through the program. You can see the scheduler, you can see what's happening behind the scenes inside the scheduler as well. You can see the job factory, you can see the job data map, you can see the log errors, job manager, all sorts of good stuff. And yeah, so that was it for this video. We tested our application, we made sure that it is working, and we also saw how it is working behind the scenes using debugger. And now the final part is basically exploring Quartz a bit deeper and seeing what other options we have with Quartz and what the kind of power it provides us. So that is what this video is going to be about. We'll be going deep inside the Quartz database and seeing what has happened behind the scenes when we actually go through the line 43, which is schedule a job. So as you can see, we did not write any SQL code, any Hibernate code, we didn't do anything other than making those tables for Quartz in the beginning. That's all we did. All we did was run a SQL file which you could get off the internet for Quartz, and then all the tables for us were created. All the constraints, the foreign keys, primary keys, all of that was handmade for us. And Quartz was handling that behind the scenes where we were running our API. Basically, this particular line of code. So let's see what's happening behind the scenes and what actually our database, how our database looks like. So go here, and these are all the tables that we have. So we have everything here given by Quartz. So we have the blob triggers, calendars, cron, etc., etc. So to be honest, I haven't used most of it. So I haven't used Quartz logs. I have never come across a situation where I had to see what is inside them, or it was always empty. Paused is when you basically pause your scheduling. So there is an option in a scheduler where you can actually pause and resume jobs. So if you have a job which is pending to be run or triggered, then you can just pause it, and then whenever you want, you can then resume the job as well. So this is what the pause trigger groups is for, where you can just see which jobs were paused. Fire trigger is basically which job was triggered and has already run at least once. Job details gives you all the information about the jobs. So let's actually see it in action now. So yeah, we are inside a console for this, and let's just do a select star from job details and see what we get back here. So if you can see on the console, we get an output. So I've actually scheduled a bunch of jobs, so ignore that part, and let's just see what is happening here. What are the columns? So we have the scheduler name, which is the Quartz scheduler. We have the job name, which is basically a unique ID. The group is email jobs, which we had hard coded inside it. Description was also hard coded. The class is the job from which it will run. So it's email job. The crux of our is durable is basically whether it's in the database or not. It is not concurrent. We haven't updated the data yet. There hasn't been any request recovery, and the job data is basically enigmatic. So there's the way of seeing that, but we know what the job data looks like. So this is basically what we see inside Quartz job details. And now let's actually see it for other tables as well. So if we do a select star from Quartz, and if I want to see all the triggers, so let's see all the triggers that we have inside our application. So we have 3 triggers right now. Again, scheduler name, trigger group, email triggers, the job name. Previous fire time, has it been fired before? -1 means no. The state of the trigger, so all the triggers are waiting. The priority is top, which is automatically given by Quartz by its own priority algorithm. We can change that, but we haven't yet. The name of the calendar, so if you're using a Gregorian calendar or something else, then it shows up here. The job data, which we give via the trigger, and the misfire instruction, basically what to do when there's a misfire. So these are all the columns we have for Quartz triggers. Similarly, you can see it for other bunch of stuff. So blob triggers, calendars, fired, log, etc., etc. So some of them are mostly empty. So let's find out which ones. As you can see, this one is basically empty because we haven't. There are no multiple instances for our Quartz scheduler, so that we can handle them. So if you're working on a microservice, then you will have this handy. If you have multiple instances running for Quartz at the same time, then you can check in the interval what was happening, which scheduler has a last check-in time, etc., etc. So this is what happens behind the scenes in the databases. And if you would want to learn more about it, then you can go inside the description below and then see how much deeper you can go with Quartz schedulers and the databases. So this is how we implemented a Quartz application which can be used to schedule email. And we did not write a single SQL command. We just ran a SQL script and it did all the work for us. And using this one line of code, which is scheduler.schedule job, we are able to populate multiple tables. We're able to schedule jobs and triggers. So this is how we actually saw how powerful Quartz is when it comes to scheduling jobs. So thank you for watching, and I'll see you in the next playlist. Good night.